Okay, let's start talking about reactions of carboxylic acids. Carboxylic acids reactions. There are two reactions that we will see, and let's do this one first, acid-base reactions. It should make sense that carboxylic acids are acids. That's why they're named like that. And if they are acids, then they will act as acids. Remind yourself what an acid does. I'll put that right here to remind you. Acids donate H+. Bases accept H+. So that's how we're going to make sense of these reactions. Donating H+, accepting H+. This is a carboxylic acid. So of course it wants to donate H+. And you should know that it's not just some random H that gets donated, it's this H right here, the H that's part of the carboxylic acid functional group. If we react this with a base, such as sodium hydroxide, you know sodium hydroxide is a base. So carboxylic acid plus a base, here's what will happen. We'll take it step by step. This H plus gets donated. Acids donate H plus. Nothing else changes. So this is still here. This is still here. That's still there. This is still here. All of that is there. Just cover up the H. That's what's left. If we donated an H plus, though, that means there's a charge on what's left behind, and that charge is negative. If H plus leaves, then the stuff left behind has a negative charge. What happened to the H plus? H plus and OH minus from the base will combine to make water. H plus and OH minus will combine. H plus from the acid and OH minus from the base. That's where the water comes from. H plus from the acid, OH minus from the base gives us water. You also know you cannot have an anion. This is an anion. Can't have an anion just hanging around by itself. It needs to be paired up with a cation. The cation is the cation of the base, sodium plus, Na plus, like that. This is the salt that we just made. This whole thing, I'll write it like this. That whole thing is the salt, and it's not just a generic salt. It came from a carboxylic acid. We're going to call it a carboxylate salt. Not just a random salt. If you got it by combining carboxylic acid with a base, we'll call that a carboxylate salt. If you can make sense of that, it's always the same. Let's say we combine this with NaOH. This, of course, is carboxylic acid. This is a base. The carboxylic acid will donate its H+. And when it does, what's left behind has a negative charge. Where did the H+ go? H+ and OH minus make water. What happened to the Na+ after OH minus became water? What happened to the Na+? It becomes the cation for our salt. Here's our salt. Again, we'll call it a carboxylate salt. Now in this course, we're not planning to name these salts, but I want you to be able to identify that this is a carboxylate salt. You don't have to name the specific salt, but you should be able to say that's a carboxylate salt, that's a carboxylate salt, and so on. There's nothing magical about the base being NaOH. Maybe it's KOH. This is the most common lab base, but it doesn't have to be that. Maybe it's potassium hydroxide. Potassium hydroxide, same thing. It's a base. So when you combine it with an acid, the carboxylic acid donates its H+, leaving this anion. H+ and OH minus make water, and the potassium ion from the base becomes the cation of the salt. Once again, this is a carboxylate salt. We'll try one more. Let's say lithium hydroxide here. Pause your video and complete this reaction. Make sure that it makes sense. Okay, hopefully you tried that. I'll show the solution. Carboxylic acid plus base. Again, the carboxylic acid donates its H+. Nothing else changes. All the rest of the molecule stays just like it was, leaving behind a negative charge. The cation is the cation of the base plus water. And this is our carboxylate salt. There you go. Get some more practice if you need it so that you're able to make sense of how carboxylic acid plus base makes a carboxylate salt. I'll also point out one thing you noticed in lab, you saw in lab, carboxylic acids, some of them are water soluble. This one was. It doesn't have very many carbons. It's water soluble. This one has too many carbons. It's not water soluble. This one probably also not water soluble. With carboxylic acids, some are water soluble, some are not. The way you find out is by determining polar, nonpolar. But carboxylate salts are not polar or nonpolar. They're neither because they're ionic. Ionic compounds like this, all these carboxylate salts are water soluble, all of them. Carboxylate salts are all water soluble.